Hi friends, today I'll be presenting my pattern recognition project named Robust Human Feature Identification System using PIFF pattern recognition. Here, PIFF recognition stands for palm, iris, face and fingerprint recognition. So let's start. Here I will be giving you a slight introduction to biometric systems. What are biometric systems? Biometric systems is a technology system which uses information about a person to identify that person. The biometric systems rely on a specific data about unique biological traits in order to work efficiently. It basically involves running data through specific algorithms to achieve a particular result, usually related to tackle the spoof, fake, or negative identification of a person and acknowledge the positive identification. Various types of biometric systems that exist currently are listed in the slide. First is DNA matching, which uses DNA samples of a person to identify the person. Finger geometry uses the geometrical parameters of a scanned fingerprint for identification. Ear recognition uses earlobe pattern of a human for identification. Gait uses behavioral biometric recognition, like walking style of a person. Rest, every other recognition system mentioned in the slide, illustrates its purpose by the name itself. The most common biometric systems used currently is face, iris, fingerprint, voice, and palm biometric systems. Now I'm going to talk about why do we need a robust biometric system. The general answer is that as the biometric systems are evolving day by day, the attack on the biometric systems or security systems are also evolving rapidly. So it is essential to make our system robust in order to maintain our integrity or confidentiality. Here are few of the types of attacks occurring on a day-to-day basis on the security system. First is eavesdropping, which occurs when someone overhears an essential or confidential data required to access restricted sectors. Data modification occurs when servers are updated with data of an restricted user to gain access to restricted sectors. Hackers concentrate more on this. Identity spoofing. They spoof the human features required for detection for security systems. Password-based attacks are very common among hackers. They hack the password-protected restricted areas. Denial of service attack occurs when critical resource or system is made unavailable for usage temporarily or indefinitely to gain access. Man-in-the-middle attack occurs when attackers alters the identification or communication between two parties to gain access. Compromised key attack occurs when a card or key of authorized person is compromised. And sniffer attack occurs when very critical encrypted interaction between two parties is compromised. Application layer attack is the same as denial of service attack but on OS level. Our project here deals with identity spoofing attacks. Rest are just as an information because knowledge is wealth. Here I will discuss the key features of my project. There are two types of live detection of fraudulent features. One where the detector uses enhanced sensors to detect features of living trait. This is called as hardware technique. One which uses extracted biometric samples for detection is called software technique. My project involves both the techniques, hence it results into enhanced accuracy, speed. It's more user-friendly and has a low cost and complexity, which as a result makes it more reliable. Let's start with my project's work's first module, palm pattern recognition. Here a multi-model approach is used for identification where we fuse palm print and palm vein images to preserve the lines. Accurately fused and enhanced image is achieved by Laplacian palm feature. Image registration is done pixel by pixel in order to achieve an accurate fused image. The approach taken for image registration is by matching a 3x3 matrix. Once image registration is done, then fused image is enhanced and multi-scale edge based area threshold identification is applied. After image registration and before edge-based area threshold identification, normalization process is also done to extract features. As target area is important, we use lapless palm technique projection, also known as LPP, to target the required area. Now matching technique is applied on extracted feature to know whether it is fake or real. Iris pattern recognition. As you know, it is defined in a simple process where an image from input image database is given to the iris recognition system. As input is received by the system, it does normalization of input image, extracts the feature, and matches the identified input with a feature database to identify whether image is fake or real. Sounds simple, right? But it is not. Here, Dogman's algorithm is used to extract or segment out the iris from an input image of eye. The Dogman's algorithm integral differential operator was used to segment along with Viterbi algorithm. After segmentation, normalization occurs, where image is converted into rectangular strip. After normalization, encoding process occurs where normalized iris is demodulated into Gabor wavelet form. In Gabor wavelet form, coefficient is phase quantized to get final encoded output in bits. Finally, the images reach matching phase where the Hamming distance is the main metric used to match extracted feature with featured database. Here, monogenic wavelets are used which has the capability to provide instantaneous phase shift to input signals. But here input signals is first passed through low band pass filter to get output more aligned in chunks. Monogenic wavelets have key features of localization of time and frequency. Hence, reconstruction of an image is done using the same. Face pattern recognition. Here we use image quality assessment technique to detect spoof facial features if there are any present in an image. An objective evaluation algorithm is used in image quality assessment. This involves calculation of mean square error and signal to noise ratio. The output from this algorithm is sent to neural network classifier where facial feature is detected to be a spoof or real. Now when input image is introduced to image quality assessment module, it is analyzed and background of the image is removed as it is not needed. Background subtracted image is converted into grayscale image, which further is enhanced and converted into a binary image. If facial features extracted matches, then we will receive result as face detected, else it will say as face not detected. In image quality assessment module, signal to noise ratio is a key factor for analysis of low-level descriptive features. Here, the calculation of SNR is done by frequency spectrum analysis, which can isolate SNR of any given image. Fingerprint pattern recognition. In fingerprint pattern recognition module, a Gabor filter is used along with canny edge detector. The two are used to filter out or extract specific feature from input image. After the specific target is extracted out, then we pass it through corner point detection method. Here, we pass the input image to do mapping of repetitive corners over various intensity of images. Here the algorithm finds specific corners which have specifically larger corner function. Thereafter it calculates the maxima points. The threshold value of Gabor filter is crucial as its value helps in extraction of features. Euclidean distance plays an important role here as its value provides a distinctive extracted feature every time. Euclidean distance is used to compute the distance between pair of pixel objects detected after feature extraction. Computed value is stored in vector set, which is used to form binary vector. The stream of binary vector will form a decimal number system which is unique and distinct for every individual and cannot be spoofed. Now I will show you the demo of my project work. This will be a case when the image is fake. Here I am loading same images of an iris. And it says that the templates are from the same eye. Now for iris, I'll load iris images of two different persons. As you can see, the Hamming distance is calculated and the template says that it's not from the same eye. Here it analyzes and finds the face within a given input image. Now I'll give you an example of a fake image. Here it processes it and finds that the face is not found in a given input image. This is how image quality assessment works. Now this is an example of fingerprint pattern recognition. Now here it's asked for the matching database. When I provide it the same, you'll see the result. And it says finger image is real. Now here I will provide an example of a fake finger pattern recognition. Now it asks me for the matching database. And I provide here the fingerprint of another person. And here it gives me that the finger image is fake. Now let's go ahead with the presentation. So at the end, I will say that it was extremely difficult to implement 4 modules within a project where every module can be treated as an individual project itself. Hope it pays off. For any queries or assistance, please feel free to contact me.